up, guys? Welcome to another AMA Ask Me Anything. I'm Taylor.
I'm Caleb.
I'm Adam.
And we're here to answer all of your deep, your dark, your burning questions about the new Spike Mill. All right. Question number one. Toss it over to you, Adam. This is from Kevin. How were the hopper sizes chosen?
Good question. So obviously we want to kind of design the hopper around what do people use the most, right? So we got two different sizes. We got the home and the pro. In our research, we found that like 95% of people are milling into 5-gallon buckets, right? It's the most easy to find, easy to handle. So we pretty much designed the home hopper to hold enough grain that you could mill completely and fill up a 5-gallon bucket. On the pro side, a lot of those folks are using milling right out of 55-gallon bags. So a 55-gallon bag of grain, you can pour the whole thing in. You don't have to sit there and wait for it to run through. And that's pretty much dictated the size of the pro hopper.
So the other thing I'll add is when we designed this hopper, we tried to make it user-friendly. And some of our competitors have hoppers that are big, bulky, tall, which makes it very difficult for a lot of our customers to fill. Now, it's not a problem for me because I'm 8 feet tall, but for somebody like Taylor, who's a little bit shorter, it's hard to get bags, buckets into this hopper. So the home is designed to be short, compact, a little bit wider. The pro is a similar idea. It's a little bit wider, a little bit bigger, but still able to get, your bucket or your bag, whatever you want, into there without any problem.
So that's actually a great segue into the fact that there's two of these, right? There's two mills. So Caleb and Adam, why did we decide to make a pro version and a home version? Because so many options out there, there's only one.
Yeah, I guess, some of our competitors, there's a lot of good mills out there, but they're pricey. I mean, 4 figures and up. And, from my perspective, why would you spend as much money on your mill as the rest of your brewing setup, right? Especially for home brewers, kind of a big barrier to entry, especially with cost once you start accumulating equipment. The mill is an important part of your setup, but it's also the very first part of your setup. You've got so much more to deal with. So we really wanted to kind of right size the equipment for the task as a portion of your entire setup. And so, don't put more material in it. Don't make it bigger than it needs to be. And that's kind of the approach we wanted to take.
And what are some of the differences between the home and pro? There's things that are the same, but obviously there's got to be some differences between the two.
Yeah, so what we tried to do is keep everything looking the same. We want to keep that same family style, make sure it looks really nice, both the home and pro. But what you'll notice mostly is the hopper size. We're looking at 15-ish pounds to 60 pounds. You're also going to be mostly noticing the throughput. So the home mill is made for more of a, smaller brewery or somebody who's not doing a ton of grain, but the pro is made to do 2 or 3 times the amount of throughput. So you can do 100 pound, 200 pound, 300 pound, whatever grain bills, and not have to wait all day to crush your grain.
Yep. And, obviously bigger unit, you're going to have more roller length, you're going to have more powerful motor, some of those things. Obviously better, long-term reliability for thousands of hours. That's all going to come into play with the bigger motor.
Love it. All right, so the next question comes in from Scott, and it is, are the rollers hardened? And the answer is yes. They are hardened through a heat treating process, and they are made of 1144 steel. And so we have these two rollers in both the home and pro made of that same material. All right. Paul writes in, will you be offering some kind of table or stand option? Good news, Paul.
Good question. Yep. So kind of along with this project, we've been thinking about how does this fit in your brewery, right? And different people have different setups. You might put this on a shelf and take it out, or you might kind of have it as a permanent fixture. So we kind of designed for both of those scenarios. So yes, we do have a table that's designed for both the home and the pro size. So we have kind of a smaller table and a bigger table. Those tables are designed to mount it, to be able to put a container bucket underneath and kind of control dust, to be able to pull that out and dump into your kettle. And then if you're a little bit more temporary and you just kind of bring it out, we definitely noticed just like everybody uses the buckets. So we found a lot of feedback that just designing a way for this mill, which is, not light, it's still got some weight to it, to be able to support that onto a bucket easily and contain everything is kind of the way to go. So we do have an adapter to be able to mount our home mill directly onto a bucket to seal it off. Everything goes right inside, and then when you're done, you could even leave it attached to the adapter and just put it on your shelf. And we think that's going to be really slick.
Super excited about the bucket adapter. Like, what material is it? Is it clear? Is it black?
So yeah, we're gonna basically form it out of a clear polycarbonate plastic.
Okay.
So even though you put it on the bucket, since it's clear, you're gonna be able to see how it's milling through and kind of when that gets full. Make sure you don't overfill, that kind of thing. So it's gonna be really cool.
Isn't that the best part too? Like seeing the grain like go through.
That is
So rewarding.
We love. Next question is from Rich, and he must have saw our social media post because he's asking, like, what about dust? What are we doing with that?
Great question. So what we are going to do about that is kind of twofold. So let's say that you decide to buy the bucket adapter or decide to buy one of the tables. That is going to help a ton with your dust problems. It's the number one problem that we hear from our customer when they're milling, and both of those solutions will really help out with dust. But it's not a required purchase when you buy the mill. So what we designed in is this funnel. The funnel really is a simple part, but it has a very important purpose. It comes standard with every mill. You're not going to have to buy it separately, and it will help you tremendously with your dust mitigation. So pretty much the way it works is it's a nozzle. We call it a funnel. And on a lot of these mills, you have rollers that kind of counter rotate, and what they do is they make a ton of dust, and when they rotate, they build kind of a flow, and what happens is it goes out of the bottom and wants to go everywhere except in your bucket, right? So what this is doing is it's containing that flow. So the grain will come in here, but it has nowhere to go, and instead it has to be forced through this tiny little gap here. What the tiny gap does is it constricts that flow to a small area, so then in the distance, say 3 to 4 inches between your bottom of your mill and your bucket, that will still expand like a mushroom cloud, if you will. But it has nowhere to go because it'll hit the side of your bucket before you have any issues with dust. So.
And this is like the number one complaint that we heard from brewers when we reached out, and it was like the dust. It just gets everywhere.
Yeah, and we experienced that ourselves with other units that we've used over the years in our brewery. I mean, just like grain everywhere. So
Yeah.
we wanted to address that.
And no one else has like such a feature, correct? This is something
Correct.
that
This
you guys
is-
really thought about.
We spent a lot of time developing this, and it looks simple. It looks, easy to use, and that's the point of it, really. But we spent a lot of time figuring out the best way to do this and to keep it simple for our users. And I think this is going to be a really good solution to dust problems.
Love it. Next question comes in from Josh, and it's, what's the advantage of 2 rollers over 3? Toss it over.
That's a good question. So if you look at all the different rollers out there, there's a lot of 3-roll systems out there, 2-roll systems. We kind of looked at a lot of the different aspects of how it would work. From our perspective, 2 rolls definitely works well, and it's a simpler approach, right? You're always trying to set a gap. Setting a gap between 2 rolls versus 3 rolls is that much more complicated. So it's more difficult for the user to dial that gap in, and you're always changing it. So, that was a big reason to go with 2 rolls. The other reason is sometimes with 3 rolls, you can kind of overcrush or kind of pulverize your grain a little bit more, especially if you don't have your gaps dialed in just right. And again, simpler is always going to be better, especially at the home brewing level. And another thing, like, you put that 3rd roller in and you're putting the cost in there. You're paying for it. You're paying, you're building that cost up. And again, you're still going to get an awesome crush with the 2-roll system. And that's why there's a lot of really good 2-rolls mills out there. So, it's simpler is better, and keep the cost down for, our customers.
Yeah, no, and along with cost is also weight too. So remember, these things are machined out of solid steel.
Yep.
And, especially for the home units where you're going to probably be moving around your brewery, you're going to move it up on a shelf, up and down, we can save 5-10 pounds just by not including that. So that's another added benefit of.
All right, so next question from Tim is, what's the difference between shearing versus crushing grain? Super good question. And in order to answer that properly, we actually reached out to a local malt company for their expertise on that like particular question as well, right?
Yeah, I mean, and from our perspective in engineering, we always try to kind of seek out the advice of experts, and we talk with this maltster about like what it means to handle the grain, what does the industry do commercially, and that kind of took that feedback and really absorbed that into our design process as we started to kind of concept out how this mill was going to look.
Yeah, so what we learned is that there's a difference between a lot of mills in the market made for baking, we'll call it, versus brewing. And we're brewers, not bakers. And what we found is that you don't want to make flour. Flour is good for your efficiencies because it'll extract more, but you'll have a harder time with stuck mashes, and it's just not worth the efficiency on this small scale. So what we did is we designed rollers that have about a 1.3 ratio in speed. And what that does is when they counter rotate, they're not just pinching, right? They're actually rotating at different speeds. So we kind of get a shearing action. What the shearing action does is it takes the outside of the malt off, exposes the inside, and not crushes everything. So it's kind of a shearing action that really tries to expose and not crush. Now, we are still crushing malt because we have the rollers that still pinch, but it's kind of a combination to try to get the best of both worlds, not make flour. We're brewers, not bakers.
Okay, next question comes in from Matthew, and he asks, what's the difference between knurled rollers and helical fluting?
Matthew, great question. This is a common question in the industry, and it seems that there's no great answers out there that you can find readily available, so I will tell you today. So, a lot of our competitors use a knurled finish on their rollers, and that works well. The truth is, you can get a optimal crush out of any roller. Now, the differences come in when you look at what crush you're going to get. Maybe on a sieve test where you're testing, your particulates versus your flours, the sizes of your grist. Maybe it all comes out the same. But when you look at the quality, what you want is some big chunks of the husk intact. What that does is it creates a nice bed on the bottom of your mash to filter water through. We found is in the knurled rollers, that husk gets broken up into tiny pieces. And what that leads to is stuck mashes, issues with brewing, and it just makes a mess. So what we did is take a page out of the pro mills book. So pretty much everybody you see who's making mills for big breweries is going to use the approach of helical fluting. Helical fluting is a process where we're not actually raising a knurl, like a knurl roller where you're actually taking the material, kind of pushing it out. We're actually removing material when we machine these rollers. And what that happens is you start to see these creases in the rollers. So the grain will actually get stuck in the creases and it will pinch against the other roller, and not to the point where it's crushing everything and tearing it apart. So that's why we went with that. It turns out to be a big difference in your quality, and it's something that like I said, you wouldn't really see maybe in a sieve test, but I guarantee you when you use it, you'll notice better runoff and you'll have a better time with stuck mashes.
So you're getting more like optimal grain.
Yes, exactly. And I think that you'll realize this after you do just a few batches. I think it's going to be night and day.
Okay, next up is from Don, and he's asking, why should I buy this mill over $100 Amazon mill and drill? Well, Don, we actually have a lot to say about that.
Yeah, I mean, it's a valid question. Obviously, like from our perspective, this mill is designed by brewers and a brewing company, right? We make brewing equipment. I think this thing has been floating around in Caleb's noggin for well over a year now, and you can tell, obviously, all of the brewing related engineering and thought that's going into this, right? So you want to get a generic anything, you can get a generic anything. And yeah, obviously, 2 rollers and a shaft and a drill, you can mill your grain. However, you only have one batch of grain, and holding the drill, you got to hold the speed. I mean, we are very tightly controlling the speed to exactly what we want for an optimal crush. These drills, they're designed to run, a couple thousand RPM. We'll try to hold that at 200 RPM so that you don't pulverize your grain, and it's, wearing out your drill, and it's just inconvenient. Honestly, we think this is a much better proposition for only a little bit more.
Well, that's a very manual way to do it, right? You're like constantly trying to figure out the speed yourself.
Right. And if you have problems, let's say you have problems with getting the mill stuck, that's what I hear a lot about. A lot of these $100 mills, they'll only have one roller that's driven, right?
Yeah.
So if you only have one roller that's driven, you have a lot more chances of getting stuck, which means you gotta let go of your drill, undo it,
Reverse
and then
it, yep.
you gotta figure out your speed again when you're pulling the trigger. It just makes things more difficult for your brew day, and we're trying to make things easier for you.
Isn't there a difference too between like, okay, let's say that you're really like spinning and on like a high velocity with your drill, is that affecting your crush?
Yeah,
Like
great
flow?
question. So if you run same batch of grain, let's say you do the same batch of grain at 200 RPM and you do it at 300 RPM, you're going to get drastically different results. And, yes, you can think that maybe you can hold your finger on the trigger exactly what you want, but the reality is it's never going to be as good as something like this, which is always going to be set at the right speed. There's both rollers are driven. You're never going to have a problem with that. You can start it, stop it as much as you want. It's always going to give you what you want.
Okay, next question is from Tom, and he asks, why a chain drive over gears and belt? Great question. We've actually thought long and hard about that, and we've got a sample unit here today to show you the inner workings of the mill.
Yeah, and again, we've kind of talked about this. We did a lot of kind of early research and talking to customers on all the mills that they've used. We talked to people who used belt-driven mills, and they were complaining about belts stretching and belts coming off and having to have extra belts on the shelf to be able to deal with those situations. And then, we talked to people who had gear-driven mills. And yeah, they run fine. Obviously, gear-driven is pretty solid until you open up the case and you see a bunch of metal shavings. Yeah. And, you've got wear, and if there's any misalignment, you got that going on. You don't even realize it until it starts making noise and making problems. So we kind of started to look at a different solution there.
Along with what Adam said about the advantages of this mill, and the chain drive, we not only designed it to outperform other solutions, but we've over-designed it. This chain is far bigger than it needs to be. We did that because there's no reason to, if you're gonna do it, let's just do it right. And we wanted to make it so you're never gonna have an issue with too much torque. You're never gonna have an issue with teeth breaking. This thing should last forever. It should crush grain for the rest of your life. Maybe your kid's life, maybe your grandkid's life.
All right, so we don't need this bad boy anymore because we've got a different question. So Sam wants to know if our rollers will have the same non-parallel issue as other mills on the market.
Great question, Sam. We thought about this extensively, and it's actually to somebody on the outside, it's a very simple thing, right? Like a lot of mills, what you have is a roller and then some way to move that roller up and down, right? What you have is, in reality, is kind of a teeter-totter. Sometimes when you move that mill, it does not move in a straight line, and you end up getting some different gaps left and right. It seems like a simple problem, but it's actually a very difficult problem to solve because we need to keep things moving nicely, freely, and without friction. So what we came up with is an idea where we have the same central shaft like you would on a teeter-totter, but then we have two extra shafts, one here and one here. And what those shafts do are they force each side to line with each other. So what happens is one side is not able to move without the other side. So you have two rails that really can keep these things parallel all times. When you set it to 35 thousandths, it's going to be set at 35 thousandths, and you don't have to check it.
Right? Yep.
Both sides, 100%.
So what does that ensure?
It ensures that when you set a gap, that's the gap you have across the entire length of the roller. And
when you're setting the gap, is it just like a simple turn, or do you have to have some type of card or contraption and measure yourself?
Yeah, so that's the advantage of being able to use kind of one central screw shaft to change the position of your roller. Is you're not setting one end, setting the other end, using kind of tightening and loosening screws and going through this whole contraption, which is really how a lot of the other mills on the market are today. And we wanted to really have just like a simple dial, based off of a linear screw, which kind of everyone understands. It's a good mechanical system. But then using those guide pins to kind of make sure that everything runs parallel and stays true across the length of the roller.
So you're going to set it and forget it. That's all. That's all our questions. That's all I got.
Sorry.
Stay tuned because we do have another engineering Q&A, which I'll get these guys back on camera. We'll get some more of our home and pro mills. They'll do a complete deep dive, the whole like engineering download. Until next time, see you later.
See you later.